handwriting guy. Okay, so guys, let's do the next part. Probability. Okay, so what's probability? Probability is like my wife is pregnant. You know, what's the probability we're going to have a boy? Well, 50% chance, right? Because you can either have a boy or girl. I'm going to flip a quarter, right? What's the probability it's going to land at tails? 50%, right? One half, right? I'm going to roll a die. Y'all ever played Yahtzee? Any kind of games that you have a die? Anybody know how many sides are on a die? Some of them are 8, some of them are 6, right? There's like it's a perfect square, right? You got 6 sides, 2 here, 2 here, 2 here. What's the probability that I'm going to roll a 5? 1 out of 6, right? Why? There's 6 numbers. How many of them are 5s? There's 1 5, right? There's 1 1, there's 1 2, there's 1 3, all the way to 6, right? What's the probability? That's the kind of stuff we're going to talk about here, okay? So y'all, one of the first things we talk about in doing probability is something called a tree diagram. We call this a tree diagram because it's supposed to look like little branches, right? If I flip a coin, it can either be a heads or a what? Tails, right? Somebody once said, well, what happens if the coin lands like this? I've never seen a coin land like this. So it's either going to be heads or tails, right? Can that happen? You know, if it does, ¿quién sabe, right? Okay. Look, y'all, the first problem here says draw a tree diagram for tossing a coin twice. Then use the diagram to find the possible number of outcomes. Okay, so let's do this. We're going to flip a coin. When we flip a coin our first time, that coin can either be heads or what? Okay, that's me flipping the coin one time. Now, we're going to do a second flip. Y'all, suppose when we flipped our coin the first time, suppose it landed on heads. When I flip it a second time, can it not still be either heads or tails? Right? And if I flip my coin, if the first time it landed on tails and I flip it the second time, it can still be what? Heads or tails. Okay, this is what we're going to do now. We're going to list or we're going to find the number of possible outcomes. What I mean by that, y'all, when I flip the coin once, it can be heads. When I flip the coin the second time, it can also be heads. That's one outcome. I can get heads on both times. Or we can get heads the first time and what the second? Tails. Or if we get tails the first time, then we can get what the second? Heads. Or we can get tails and then what again? These are what we call our outcomes. How many different outcomes do I have here? 4. There's 4 different possibilities that we can get. We can either get heads, 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 tails, tails, heads, or tails, tails. Those are the 4 options that we can get when we do this here. Okay. Now, next problem, y'all. Same type of problem. Draw a tree diagram for tossing a coin. How many times? Okay, so look, we're going to do the same thing here. We're going to come back here. Look, this is our first toss. We can either get heads or tails. Okay, we're going to flip the coin a second time. Okay, we can either get heads or tails, right? But we're going to have to flip it how many times? So look. Do you see the little game I'm playing here, y'all? Okay, good. Now, what we want to do, y'all, we want to list all the possible outcomes. Okay, so y'all, when I'm listing my possible outcomes, what I'm doing, y'all, is I'm just going down the branches. So look, heads, heads, and heads, or heads, heads, and what? There we go. Okay, let's go through all of them. Heads, tails, and heads, or heads, tails, and tails, right? Right here, heads, tails, and tails, right? Now let's do that again. Look, tails, heads, and heads. Or tails, heads. Do you see what I'm doing? Okay. Or tails, tails, and heads. Or tails, tails, and tails. Did that make sense? I was able to do that, y'all? Just going through each. Okay. Now look, y'all, I got a question for you. We're going to count how many different possible scenarios we have. 2, 3, 4, 5, 6. Very good. We got 8 different possible scenarios. Now, y'all, I want you to think about the same thing here, but instead of flipping a coin and getting heads or tails, suppose you're going to have 3 kids, right? That's already, some people say it's already too many, right? But look, suppose you're going to have 3 kids. Your child, y'all, can either be a boy or a girl. You see what I'm doing? A boy or a girl, a boy, you know what I'm saying? So you can do this. That was supposed to be girl there. Boy, girl. And you can do this and you can figure out the same kind of thing when you have kids. What's how many different possible scenarios? So if you have 3 kids, there was 8 possible scenarios. Change all the H's to boys, change all the tails to girls, and boom, you got all the possibilities right there. Okay. So look, y'all, probability event says the number of ways that event can occur divided by the total possible number of outcomes. Okay, so look at the first one that I have down here, y'all. It says if a coin is tossed twice, find the probability of tossing a heads on the first toss and then again on the second toss. Okay, what I want to do here, y'all, I'm going to come back to the first problem that we just did. I want to look for the total number of outcomes. When we tossed a coin, how many times? Twice. Okay, so look, when we tossed the coin twice, how many different outcomes did we have? We had 4. Okay, so look, y'all, this part here, it's going to be out of 4. I want to know how many of those 4 had heads. So if I come back over here, how many of those 4 here had heads? Just one of them. So what's the probability of getting a heads on both shots? 1 out of 4. Does that make sense? Okay. And that's how we're doing that part there, y'all. We're looking at all of our outcomes. Which one of them had heads? There was only one of them, 1 out of the 4. Okay, if a die is rolled 1 time, find the probability of rolling it 3 or 4. Okay, y'all. So again, just to give you a heads up, y'all, this is what a die looks like. Okay, so there's a 1 here, there's a 1, 2 there, there's a 1, 2, 3, 4 there, maybe a 5, right? You've seen die before, right? They look like that. Okay, so when I roll a die, y'all, I have 6 different possible scenarios. I can land on a 1, a 2, a 3, a 4, a 5, or a 6. So that tells me that my total, y'all, is going to be 6. There's 6 different options I can get. Okay. Look what it says. Find the probability of rolling a 3 or a 4. How many numbers are 3 or 4? 2 of them. 2 out of the 6. Y'all, can we reduce that fraction to what? 1/3? There you go. Right? And people say, how did you get 1/3? We divided them both by 2. Right? 2 goes into 2 once, 2 goes into 6 3 times. Okay, if a die is rolled 1 time, find the probability that the outcome is less than 4. Okay, so remember, my total possibilities, y'all, is 6. Okay, I want to know how many numbers are less than 4. 3 out of the 6, right? Aren't 3 numbers less than 4? Okay, can we reduce that? Yeah, we can divide them both by 3, 1/2. Y'all, with probabilities, remember I told you the other day, if you watch Tim Smith, he says, look, there's an 80% chance it's going to rain today. Guys, my probabilities always go between 0 and 100%. Tim Smith is never going to tell you, hey, there's a 150% chance it's going to rain. He'll tell you it's either going to rain like there's a 100% chance or there's no chance of rain, meaning it's 0. But it'll never be more than 100 and it'll never be a negative number. It's always going to be between 0 and 1 or a number between 0% and 100%. Okay. So all of my answers, y'all, are either going to be fractions, they might be little decimals, but this is what I'm doing, right? And you say, what do you mean by decimals? We know how to convert 1/3 to a decimal, right? We can take our calculator, 1 divided by 3 or 1 divided by 2. That's what I mean. But they're all going to be numbers like that. Okay. Probability is always a number between 0 and 1 or between 0% and 100%. Okay. Y'all, for these problems, for these next problems here, this is the way I normally do this problem. It says, find the probability of choosing a red marble from a box that has 1 red, 1 yellow, 2 blue, and 4 green. So look, let's do this, y'all. Bless you. Let's do this. I'm going to put 1 red marble. I'm going to put, let me go like this. Do we got a yellowish here? That's yellowish enough. Bless you. We're going to go right here. There's one yellow. How many blues do we have? Two. How many greens do we have? One, two, three, and four. Okay. My question to y'all, number one, what's my total number of marbles? Eight. We got a total of eight. Okay. Look, y'all, we're trying to find the probability of picking what kind of marble. How many are red? There you go. 1 out of 8. Does that make sense? All we did is now, guys, what helped me the most? Looking at that very rudimentary picture, right? Real basic, but now I know how to do a probability. Okay, we're going to do the same thing. Find the probability of choosing a blue marble from the same box. Y'all agree the total was still 8, right? Okay, how many are blue? Two. Can I reduce that fraction, y'all? 1/4? Perfect. All right, let's do the same thing here. Let's do the same thing here. Look, remember, the total is still 8. We want to know how many are blue or how many are green. So we have a total of 8. Blue or green, how many are those? 6? Can I reduce that, y'all? 3/4? Good. Divide them both by 2. Okay. Last one, y'all. 8 marbles total. How many are red or yellow? There you go. 2 out of the 8, 1/4. And there we go. Guys, what do you think about probability? Not too bad, right? Yo, what helps a lot is when you have a picture, because a picture, a lot of us, I think, especially me, I'm a visual learner. So when I have that picture, it's easier for me to understand, right? Good, good. Okay, guys, I apologize about your copies. I know they're not in color. They're just gray, and a little bit more gray. But I think what helps in these problems is that, like this problem here, I mean, I don't really need the colors because it's asking me more about the numbers. But look what it says. Suppose the spinner shown, we're going to spin it one time, right? So we're going to spin it. We're going to see where it lands. Find the probability of each event. Y'all, how many different regions do we have there? Okay, so we know that our total is going to be 3. Okay, so look, let's do number 19. The result of the spin is a 2. How many 2s? Okay. The result of the spin is a 3. How many 3s do we have? Just 1. Okay. Okay, look. The result of the spin is a 1, 2, or 3. How many numbers up there are 1, 2, or 3? 3 of them. 3 out of 3 is 1, right? The whole thing. So remember what this is asking me. What's the probability that I'm going to get a 1, 2, or 3? Because those are my only options, right? We're guaranteed to get a 1, 2, or 3, right? Okay, look at the next one. Look at 22, y'all. The result of the spin is not a 3. How many numbers up there are not a 3? 2 of them, right? So 2 out of the 3. Okay, odd numbers. Remember what odd numbers are? 1, 3, 5, 7, so on and so forth. How many numbers up there, y'all, are odd? 2 of them, right? 1 and 3 are odd, so there's 2 of them. So how many are even? Just 1. Okay, good, y'all. Most people do fairly well with the probability stuff. Again, I just want to make sure that we all feel good about these problems. So what I'm hoping is when you leave here every day, y'all, you're like, okay, I'm feeling better about this. Look, y'all, the next problem here says a new drug is being tested that's supposed to lower blood pressure. The drug was given to how many people? Okay, this is my total. Let me make that a little bit smaller. There we go. Boom, that's my total. Okay, 152 of the patients had a lower blood pressure. 38 had a higher. We definitely don't want that. And 10 had no change. Okay, it says, what's the probability that a patient had a higher blood pressure? Well, we know we had a total of 200. How many of them had higher? Okay, so look, y'all, let's reduce this. I say we can divide them by 2. What's half of 200? 100. Anybody know what half of 38 is? 19. So 19 out of 100 are going to have a higher blood pressure. Okay, what's the probability that a patient had no change or a higher blood pressure? No change was 10 and a higher blood pressure was 38. So that's a total of how much? 48 out of the 200. Okay, y'all, again, we want to reduce this. What do you think we can divide them both by? Okay, we can go by, let's keep it small. Let's go by 2. So look, y'all, half of 48, 24. Half of 200 is 100. Okay, again, I want to make sure y'all, if you wanted to go by 4, that's fine too. I'm going to go by 2 again. What's half of 24? 12. Anybody know what half of 100 is? Okay, can we go by 2 again? 6 over 25, and then it looks like that's where we would stop, right? Again, remember, y'all, when you're reducing your fractions, if you want to go by 4 or by 8 or something like that, you're more than welcome to do that, right? Okay. Again, I apologize about the copies, guys, but they did put a little Y and all that kind of good stuff on there for yellow, red, blue. Okay, a single choice is made from the group of marbles shown. Find the probability, bless you, that a yellow marble is chosen. Y'all, what's the total number of marbles? 2, 4, 6, 8, 9? 9 marbles total. How many are yellow? 2 out of the 9, right? So remember, y'all, when we're doing probabilities, remember, it's going to be a fraction, right? 2 out of the 9. It wouldn't just be 2. It's 2 out of the 9, okay? Let's see. Same type of problem here. I want to count. How many marbles do I have? 2, 4, 6, 8. Still got 9 marbles. Green. How many are green? 2 out of the 9. Okay. Let's see. Okay. A single choice is made from the marbles shown. 2, 4, 6, 7 marbles now, right? Find the probability that a blue or a green. So blue or green, I got 1, 2, 3, 4, 4 out of the 7, right? Are y'all hoping you get a bunch of marble problems? Good. Me too. You do get a lot of problems like dealing like this? Okay, so good, y'all. Again, when I took the test that day, I went in there, y'all, and I took it as if I was a student. So like I remember when a bunch of us went to go take it, right? And there were some people they were like they wanted to get every question right. But like to me, that's not the point. Because again, remember what I told you, the test is adaptive, right? If I get, say, the first 12 questions right, then the 13th one is going to be a harder question. Because they're going to say, you know, this guy knows a lot of math already. Let's see how much more math he knows. Like maybe this person can go into trigonometry or you know what I'm saying? So the test goes like that. But the point of it, I think for us to take it, us, what I mean by us, the instructors, was let's get some problems wrong so that when we do this kind of a setup, we know what kind of questions they're going to ask you guys, right? And so my idea was like, I would get question 1 and 2 right, but I'm going to miss number 3. I would get question 4 right. Let me miss number 5. You know what I mean? I was trying to miss enough questions so I could see what they were going to ask me. And guess what? I got the other 40, right? I got that second 40. So I could see again, what kind of questions. Guys, I saw a lot of stuff doing with stats and probability stuff. That's why I really wanted to cover that. Now, y'all, the second thing I'm going to do here is something we call unit analysis. It's just a fancy word, but a lot of the stuff some of the stuff I would say we definitely know. Like I would say off the top of our head, I think most of us are pretty familiar with the time thing. 60 seconds in a minute, right? 60 minutes in an hour, and stuff like that. Now, when it comes to length, weight, volume, that we may not be as familiar with. But the one thing I want to say, like, what should you know? You should definitely know the time thing, right? That's something most of us learn in elementary school. So if you haven't learned the time thing, learn it, right? I'm not necessarily saying you're going to get a ton of questions like this, but there was a couple of questions where you had to do a little bit of converting here. Now, in terms of length, I think everybody should know there's 12 inches in a foot, there's 3 feet in a yard. Do you necessarily have to know off the top of your head there's 5,280 feet in a mile? No, I don't think you necessarily need to know that. 16 ounces in a pound. I mean, some people know it, some people don't, you know, but the time one, and at least the first 2 for the length, y'all, you should know. Now, what I want to show you here is how to do these problems so that they work out perfectly every single time. Okay, what I want to show y'all is we're going to do some converting. We're going to convert feet into yards. Okay, so the first thing I'm going to do, y'all, I'm going to rewrite this problem right here. I'm going to write 27 feet. I'm going to write that over 1. Now, I want you to notice, I want to get my answer in what? In yards. Okay, So I'm going to go back to my little chart and I want to say, hey, do I have something that converts feet to yards? Right here. 3 feet is the same thing as what? 1 yard. Okay, so look, y'all. If if I want to end up with yards in my answer, I'm going to put yards on top. If I have feet up here, I'm going to put feet down there. Okay. Now I'm going to use this little piece that we have. Everybody agree 3 feet is the same thing as 1 yard? So look, we're going to come back this way. We're going to put 3 feet, 1 yard. Okay. Y'all, the way we multiply fractions is we go straight across. 27 times 1 is? 1 times 3 is? Okay. Anybody got a calculator? Anybody know what 27 divided by 3 is? There's your answer. Is it going to work like that every time? Every single time it's going to work. Whatever units I want to end up with is the one I'm going to put on top. Whichever one I have here is the one I'm going to put on the bottom. Okay, look, y'all, let's do the same thing for this next problem right here. Okay, so look, first thing I'm going to do, y'all, 63,360 feet. I'm going to write this over 1 times something. And I know that I want my answer to be in miles. Okay, so look, y'all, we have something that converts feet to miles. We know that 5,280 feet is the same thing as 1 mile. Since I want to end up with miles on the top, I'm going to put miles here. Since I have feet here, I'm going to put feet right there. Okay. Now, I'm just going to fill in the numbers. 1 mile is the same thing as 5,280 feet. Okay. Y'all, I'm going to cross multiply. Or I'm sorry, multiply straight across. 63,360 times 1 is still 63,360. 1 times 5,280 is still 5,280. Let's take our calculators. Let's divide that out. 63,360 divided by 5,280, 12. 12 miles. And we're done. It's going to work like that every single time. Okay. Look, y'all, let's do the same thing for the next one. 27 inches into feet. I'm trying to keep everything on here so I can see it. So let me do it like this, but I want to make sure that you guys can see everything too. Okay, so I'm going to write 27 inches over 1 times something is going to be my answer in feet. Okay, so I want to end up with feet, so I'm going to put feet on the top. I have inches here, so I'm going to put inches on the bottom. And we know that 12 inches is the same thing as 1 foot. So I'm going to multiply straight across, y'all. That's 27 over 12. If I take my calculator, 27 divided by 12 is 2.25. There's my answer. Well, what I want you to understand is the process is, what do I want to end up with? I want to end up with what? Feet, right? So where am I putting the feet? On the top, right? What units do I have here? Inches. So where am I putting the inches? On the bottom, right? Now, am I always going to divide? Well, in this case, I have, right? But there may be some cases where I don't necessarily have to divide, but I'm going to multiply. Okay, but what I want you to understand is the important part is knowing what units to put on the top and what to put on the bottom, because it'll always work. So look, y'all, 8 tons to pounds. So look, y'all, I'm going to write it like this. 8 tons over 1 times something equals my answer in what? Pounds, right? So what do we want to end up with? We want to end up with what? Pounds. So look, y'all, I'm going to put pounds right here. I have tons here, so I'm going to put tons right here. Look, y'all, 2,000 pounds. So I'm going to put it 2,000 on top. Is the same thing as how many tons? 1. Multiply straight across. What's 8 times 2,000? 16,000? 16,000 over what? What's 1 times 1? 1. And isn't 16,000 over 1 the same thing as 16,000 pounds? What did I divide by here, y'all? What was the number on the bottom when we divided? Did it really change anything? No. But that wasn't the important part to me. The important part was whatever units I have here, put them on the bottom. Whatever units I want to get with, put those on the top, and it's always going to work. And you never have to worry about, hold on, do I multiply? Do I divide? I multiply straight across. And at the very end, I divide. And if I divide by a big number, that's fine. And if I divide by one, that's okay too. But I understand this is how I'm going to do my process, and it's always going to work. I'm sorry, what? Yeah, let's come back over here. Look what we have. We have what? Tons. And we want to convert that into what? Pounds. Okay, so look, 8 tons over 1. Here's my conversion, right? I want to end up with pounds. So I'm going to put pounds on top. I have tons here. So I'm going to put tons on the bottom. Okay. The number for the pounds, 2,000, right? The number for the tons is how much? 1. Multiply straight across. What's 8 times 2,000? 16,000. What's 1 times 1? Still 1. But 16,000 divided by 1 is still 16,000, right? So again, the important part, if you got tons here, put tons right there on the bottom, right? And whatever you want to end up with is the units that are going to go on the top. And it's always going to work every single time. Okay. All right. So look, y'all, we got a couple more. Let's go through these here. 7 gallons to quarts. Okay. So look, y'all, I'm going to write it like this. 7 gallons over 1 times something is going to give me my answer in quarts. Okay. So look, y'all, I'm going to scroll right here because this is the part that I'm looking at. 4 quarts is the same thing as how many gallons? Okay, so look, y'all, if I want to end up with quarts, I'm going to put quarts on the top. If I have gallons here, y'all, I'm going to put gallons on the bottom. Does that make sense? Okay, look, y'all, 4 quarts, oops, sorry. 4 quarts is the same thing as 1 gallon, right? Let's go straight across. Anybody know what 7 times 4 is? 28. 1 times 1 is? And 28 divided by 1 is still? And there you go. Right? And I don't ever have to worry about, because sometimes you'll say, hold on, do you multiply or do you divide? I multiply first, then I divide. If I divide by a number that's not 1, that's fine. But if I divide by 1, it's just my same number. And I don't, because that's the part that's important, making sure that the units match up. Okay, look, y'all, we got one last one to do here like this, and then we'll do the next little bit. 3 miles to feet. Okay, so look, I'm gonna go 3, oops. I'm going to go 3 miles over 1 times something is going to be my answer in feet. So I want to end up with feet, so I'm going to put feet on the top. I have miles right here, so I'm going to put miles on the bottom. And I'm going to come back over here, y'all, and I'm going to look at this piece. 5,280 feet is the same thing as 1 mile. So 5,280 over 1 mile. Now again, y'all, my miles are going to cancel out. 3 times 5,280. 1580, 40? Over how much? Over 1 is the same thing as 15,840. Very good. You got it, y'all. Okay. Now, again, y'all, the reason I wanted to go through this part right here, it's not like you're going to have this part of a question on a test, but I want us to know how to do the conversion bit. Okay. Again, if you have to do any kind of a conversion, y'all, the ones that they're going to expect you to know, I'm going to say is stuff regarding time. Okay. If you have to convert like gallons or quarts, I'm going to tell you they're probably going to give you that conversion. You don't have to memorize it. Okay. But what I want you to think about is like, let's look at this problem here. These next 2 problems, y'all, are problems that you would more likely see something like this on the test, where we're still going to have to do a little bit of converting here. Look, y'all, it says Amy left her car in the parking garage for 3.5 days, but the garage charges parking per hour. We want to know how much is Amy going to have to pay for parking. So look, y'all, how would I do this conversion? Right now, I know my time, but we know our time in what? In what? In days, but they charge me by the what? Okay, could we convert 3.5 days to hours? Okay, so look, let's do it like this. How many hours are in a day? Okay, so could we say 3 times 24, that's 72 hours? But that's only 3 days. We need another half day. What's half of 24? So wouldn't we say, look, we got to add another 12 hours, right? So 3 days would be 72 plus another half, that's 12. That's 84 hours, right? How much do they charge us though? 250 per hour, right? So now look, now we're going to multiply that by 250. So look, 84 y'all times 250, $210. Man, that's a lot of money for parking. Boom, there we go. But did that make sense how we're able to work this out? Again, y'all, what I want to mention is these are the types of problems you would see something more like this, right? They're not just going to say, hey, convert this to that. They're going to give it to you in the context of another problem, and you're going to have to figure out that little bit of a computation, right? Okay, look, y'all. Bella bought 24 ounces of pickles. If pickles sell for $2 a pound, how much did Bella have to pay? Okay, so yeah, we're going to figure this part out right now. Look, they charge us per what? Per pound. And we know how much pickles she bought, but we know it in what? Ounces. Okay, so look, y'all, is there a conversion for ounces and pounds right here? Sorry, it's a little messy. What, 16 ounces is the same thing as how many pounds? 1 pound. Okay, so look, could we convert 24 ounces to pounds? Okay, so look, y'all, can I go like this? 24 over 1 times, look what I want to end up with. I want to end up with what? Pounds. So look, we're going to put pounds on the top. What do we have here? That's what we're going to put on the bottom. Notice, y'all, that 1 pound is the same thing as 16 ounces. Let's go straight across. Okay. So look, this is going to be 24 over 16. Let's just divide it out and see what we get. 24 divided by 16 is how many pounds? Look, so we go straight across, right? So 24 times 1 is 24. 1 times 16 is 16. 1.5 pounds, right? Boom, 1.5 pounds. Now, when Bella went to buy 24 ounces, that means she really bought 1.5 pounds, right? If they charge us how much per pound? $2. Can we figure out how much she's going to pay? We're going to multiply it by how much? By 2. 1.5 times 2. How much money Bella got to pay? $3. But does that make sense on, again, how the way the problems are going to be worded? They're not just going to ask you to do a straight conversion. They're going to give you the conversion in the context of another problem, okay? And so that's why I was doing the problem like that. Okay. Okay. So y'all, let's talk a little bit about geometry. Okay, a little bit about geometry. Perimeter, y'all. Perimeter is what we call the distance around a figure. Okay, so look, all we want to know is if we were to walk from one corner to the other corner, all the way around, how far would we have walked? Okay, guys, if that's 3 yards, you agree that's 3 yards too? Right? If this side here is 3, you agree that one's 3? If this one is 2, is that one also got to be 2? Okay, what are we going to do? We want to find all of it up, add them all up, right? Adam and Eve. So look, let's find the perimeter. We're going to take 3 plus 2 plus 3 plus 2. What's 3 plus 2? 5. And another 3 plus 2 is another. So that's going to be a total of, there we go. Okay. Look, y'all, it looks like home plate, but a little bit crooked. So let's add them all up, right? Perimeter means just add them all up, y'all. It's just if you walk around the whole thing, right? So look, I'm going to start with 15 plus 8 plus another 8 plus 10 plus 7. and I'm coming up with 48 feet, right? This is what perimeter means, y'all. Perimeter is just the distance around an object, right? Okay, whoa, let's take a look at these next two and see if we can't figure them out. Okay, look, y'all. I know that this side here is 28, okay? And I know this side here is 20. If the whole thing here is 28, but from there to there is 20, would you all know how much that piece would have to be? 8. Okay, good. Now, we got one more piece to do, y'all. Look, if I know the bottom piece here is 20, but this part here is 17, how much would that little piece right there have to be? 3, right? Because it has to add up to what? To 20, right? Okay. Now, can we just start adding them all up? So we're going to go 28 plus 20 plus another 20 plus 3 plus 8 plus 17. And let's see what we come up with. 28 plus 20 plus another 20 plus 3 plus 8 plus 17. Anybody get 96? Yes. Okay, 96 meters, right? Okay. All right, let's see if we can do this one here too, y'all. Let's take a look, see here. Look, I know the whole bottom is how much? Yes, sir. Okay, excellent question. So do you agree with me that this whole piece is 20? Okay, that's 17. So if I take the difference, it's 3? Good, good. Look, y'all, take a look here. Y'all agree this bottom piece is 30? Okay, look, this is 13. How much would that have to be so that 13 and that would add up to the 30? 17. Very good. Okay, look, y'all, let's do the same thing over here. Look, this top piece here is 13, right? Well, look, if from here to here is 6, how much would the rest have to be? 7. So isn't that going to be 7 then? Because if from here to here is 7, doesn't that mean from there to there it's got to be 7 too? Okay, so look, y'all, let's start adding them up. I'm just going to go like this. So 7 plus 30 plus 13 plus another 13 plus 6 plus 17, 86. Okay, 86, what, inches? Okay, there we go. Again, y'all, when you're taking your test, remember, they're going to give you a calculator. The calculator will appear on the test itself, and it'll look something like this. It'll look something very basic. If it's just if they're just asking you to do like a simple problem like adding, it'll be like that. If they're asking you to do something where you have to have exponents like powers, big powers, it'll look something like this, and this is going to be my exponent button. Okay, and we're going to get to that as we go through the next couple of days. Okay. All right, let's take a look. Let's see if we can find the perimeter here. Look, y'all, similar type problem, right? Okay, I've got a question for y'all. Could you tell me, I don't necessarily want you to tell me the answer off the top of your head, but could you tell me what numbers would I add to get that bottom piece? 9, 10, and 8, right? Good. 9 plus 10 plus 8. I want to say, y'all, that's going to be 27. Okay. Let's see. Y'all, so let's make sure we know all the sides. Anybody know how much this side here would be? That's going to be 15. Okay, perfect. We're doing great. Okay, so look, we got this side here. We got that side there. We got this one. We got this one. We got this one. Oh, what about this one here, y'all? 7? Okay, that's going to be 7 meters también. Okay, we got 9 here and we got 15. So y'all agree we're just going to add them all up? Okay, so let's do it. Let's start. I'm going to start y'all with the 27. So I'll start 27 plus 15 plus 8 plus 7 plus 10 plus 7 again plus 9 plus 15, 98. There's my answer right there. Boom. Okay. Okay. Let's see, y'all. The next one here says a metal strip is being installed around a workbench that is 10 feet long and 3 feet wide. Okay, so look, y'all, I know, I'm not a carpenter by any means, but I know what a bench looks like. Looks something like this. And it says it's 10 feet long and it's 3 feet wide. Okay, so they're putting a metal strip. So what does that mean? They're going to be putting something that's going around this, right? Isn't that what we call the perimeter? Okay, so look, y'all, if that's 10, then that got to be 10 too. And if that's 3, then that got to be 3 too. So 10 and 10 is what? 20 plus another 3 and another 3 is 26. Okay, 26 feet is the perimeter. But look, the stripping, the little purple stuff we put along, y'all, they charge me how much per foot? $3. Can we multiply this by 3 now? So 26 times 3 is $78. Good, y'all. Y'all doing great today. I'm really happy you guys are doing so well. All right. So look, guys, we got about an hour and 10 minutes left. Right. I'm gonna take a deep breath. I'm gonna get some water because I'm surprised I haven't drank any water yet. I'm gonna go home with a dry throat. Okay. Let's talk a little bit about circumference of a circle. Yo, the circumference is the same thing as the perimeter. We call it circumference because it's a circle, but it's just the distance all the way around it, okay? So, look, y'all, we have a couple of pieces of information here. The way we find the circumference of a circle is we use this little formula here, and the formula says we're going to take, pi times whatever the diameter is. Y'all, the diameter is always, the distance that goes all the way across. Okay, we want to find something we call an exact answer and then something called an approximation. Okay, so the formula says, look, we're going to use pi times d. So the exact answer, y'all, would be pi times 17 centimeters. And the exact answer, y'all, this is what we would call the exact value. Okay, we just call it 17 pi. It's exact because I want to see if, hold on guys, I want to see something here. If I go to my scientific calculator, okay, do you see right here is the little button for pi? Look, y'all, look at the number it gave me on my problem. It says pi is going to be what number? Okay, so maybe if y'all took geometry in high school, you might remember seeing pi is 3.14. But if I hit my calculator, look what it tells me. 3.14 and then a ton of numbers after that, right? Because it's one of those numbers that repeats, it goes on forever, and it never stops. So we just decide, well, let's cut it off at 14, right? We don't need all that other stuff. That's what we call that part an approximation, okay? So the exact answer, y'all, has the pi symbol. Now, if I wanted to find the approximation, we're going to take 17 times 3.14 centimeters. So look, let me just come back to my basic calculator. 17 times 3.14. And now I'm coming up with 53. Guys, if I was going to round to one decimal place, would you say 53.3 or 53.4? 0.4, right? Okay, good. This is what we call the approximation. Okay. Now, look, y'all, I'm going to do the same thing for the second picture that I have. Now, remember, y'all, the formula that we have says C equals pi times D. Remember, the diameter goes all the way across. Well, if that piece is 8, how much would the whole thing have to be? 16. Very good. So look, y'all, it's going to be 16 miles because it's mi for miles, right? So 16 pi miles. This would be my exact answer, okay? Now the approximation says, look, we're going to take 16, but we're going to multiply it by how much? 3.14, right? Okay, so look, y'all, let's do that here. Let's go 16 times 3.14. Okay, question, y'all. If I wanted to round this to one decimal place, would you say 50.2 or 50.3? Perfect. You guys know how to round like nobody else. Boom, 50.2. Excellent, y'all. Very good. Question? Are we good? We're good on doing this stuff here? Yeah, of course. Yeah, it's always going to be 3.14. There's a couple of times when they use a fraction for the approximation for it. But the one thing, so guys, I'm going to mention this real quick. She had a great question. Her question is pi always going to be 3.14? For the most part, yes. There's a handful of problems where instead of you using 3.14, they give you a fraction to approximate it. And if you see a fraction, then they'll tell you, hey, use, and the fraction is going to be 22 over 7. But it's either going to be 3.14 or it'll be 22 over 7. Again, I took this test like almost 2 years ago, right? I remember 3.14. I don't remember 22 over 7, but what I don't want you to, I don't want you to, if you saw it, I wouldn't want you to say like, oh my God, what do I do now? I would do it the process the same way. I think we might have a problem like that, and I'll show you that in a second. The 3.14? Okay.
Quick question.
Yes, sir.
What's the difference between the exact answer and the approximation?
Okay, so
The formula.
well, so remember, good question, y'all. His question is, what's the difference between the exact answer and the approximation? Y'all, I want you to notice something. The exact answer has what in it? Has the little pi. Okay, and the reason being, y'all, pi is what we call an irrational number. If remember when I pulled it up on the calculator, it was 3.14159. It had a whole bunch of numbers after that. That means that that number keeps going on forever and ever and ever. So I don't know if y'all, when y'all took math in high school, just because math teachers were nerds, right? Some of you might have had a teacher, or at the top of the room, they put 3.14 and it went all the way across. And it was like it went all the way across the board of the room. I remember I had a math teacher like that, right? Because it's letting you know that that number never stops. So the reason when we say the exact answer like this, because that's just exact, right? This is an approximation because remember it went on forever, but we decided we're going to cut it right there. That was enough for us, right? So that's why they call that the approximation. But it's an excellent question. I'm really glad you asked it. Okay, so y'all, the next thing we're going to talk about is area. Okay, so remember, perimeter, y'all, measures distance. Like if I was going to walk from starting from this corner, walk all the way across, all the way right, all the way over here, that would be perimeter. Area refers to the actual floor. So if any of you have a home and you have redone the floor in your house, when you buy tile, they sell it by the square foot. When you buy carpet, they sell it by the square yard, right? But it's the covering of the floor, okay? Now, y'all, one thing I want to mention about area. Remember when we did perimeter? What was the operation? What did we do with each of those numbers all the way across? We added. Okay, y'all, I want you to notice something about the area. All of them are going to be multiply. Okay, we're going to multiply every single one of them. Okay, and we'll go through, y'all. Again, if you have problems on your test regarding area and stuff like that, they will give you some of the formulas. Okay, one of the things I would say is just remember area, you're going to be multiplying. Okay, so look, let's see if we can't figure this thing out. We're just going to multiply. For the area of a rectangle, y'all, the formula is the length times the width. Okay, so we're going to multiply our two numbers together here. People often ask me, sir, what number do I put first? The nice thing about multiplying, y'all, it doesn't matter. When you multiply, it doesn't matter what numbers you put first. The one thing I do want to mention, though, y'all, is the units. Anytime we're talking about area, whatever units I have, what I mean by units is whether it's feet or meters or yards or inches or whatever, right? The units are always going to be what we call square units, meaning meters squared, feet squared, yards squared. Like I said, if you redo the floor in your house and you buy tile, they sell it to you by the square foot. If you decide I want to put new carpet in my bedroom, they sell it to you by the square yard. Okay. To give you an example of what I mean, y'all, and I'm just going to kind of show you this on the side, and I'm going to do it with a real simple problem. Let's find the area. Now look, I'm going to draw a picture that looks like this. I'm going to say that's 3 feet. I'm going to say that's 2 feet. Okay, look, y'all, if this side, if from here to here is 3 feet, would you agree that I could draw a line in the middle and that this would be 1 foot and that would be 1 foot? Would that make sense? Okay. Now, if I told you from here is 3 feet, could I draw a line here and another line here, and each of those would be 1 foot? Now, I know I didn't draw it as pretty. I was trying to draw them where they were all little perfect squares. But What I want you to notice, remember how we find the area? We multiply straight across, or we multiply the two numbers. What's 3 times 2? 6, right? Why do we call them square feet? Because 1, 2, 3, 4, 5, 6. I'm supposed to have, I didn't draw a picture of this pretty. I'm supposed to have 6 little squares. I know they're a little more like rectangles, but because they're little squares, that's why we put feet squared. Does that make sense? Same thing with whether it's feet or meters or inches, it doesn't really make any difference, okay? But the idea is the units, y'all, are also square units, okay? Yeah, so for a triangle, y'all, the formula for the area of a triangle is going to be the base times the height divided by 2, or 1/2 the base times the height. They both mean the same thing. Okay, remember, all you're doing here, y'all, is you're multiplying. The nice thing about multiplying, it doesn't matter what number you put first, okay? So whether you go 5 times 6 divided by 2, or whether you go 6 times 5 and divide it by 2, 5 times 6 is 30. 6 times 5 is still 30. What's half of 30? 15. Okay, look, y'all, if we have yards, I'm going to put yards what? Squared, right? Remember, my units, y'all, in regards to area, is always going to be square units, right? Feet squared, yards squared, meters squared, inches squared. Whatever units I have, it's always going to be square units. Okay. Okay. Let's take a look at the next one. Parallelogram. Y'all, the formula for the area of a parallelogram is the base times the height. Again, the nice thing about multiplying, y'all, is that it doesn't matter what number you multiply first or what number you multiply second. So I'm going to take 5.25 times, in this case, 7, and I'm coming up with 36.75. What are my units, y'all? Feet, what? Squared. Good. 36.75 square feet, feet squared. It all means the same thing. Well, yeah, because sometimes it'll ask you, what are the units? Is it feet or is it feet squared? So that's why you got it. That's why I'm just saying, just you don't have to think too hard. Just remember, if it's area, whatever units I have, there's going to be a little what on top of it, a little 2, right, for the square, right? That's the part you got to remember. Yeah. Square feet, yeah. Or it might say SQ feet, right? Like square feet, right? Y'all, take a look at this one here. Let me ask you a question. If I wanted to find the area, right? This kind of looks like a letter L. Could we do this? Could we say, look, let's cut this right here and let's call this rectangle 1 and let's call that rectangle 2, and we can find the area of each of them and then we'll know what the total area is? So look, y'all, if I wanted to do, say, the area of rectangle 1, I'm going to take the length times the width. So I'm going to take 10 times 5. Wouldn't that be 50 square miles? Okay. Now, if I wanted to find the area of rectangle 2, I need to figure out how much is it from there to there. So look, y'all, if the whole thing from here to here is 17, and if this piece is 5, that piece got to be 5, how much would this piece from here to here be? 12, right? Everybody agree that's got to be 12? Okay, so look, are we going to take the length times the width? So we're going to take 12 times 3, that's 36 square miles. So what is the total area, y'all? Very good. Excellent, y'all. Very good. And that's how we do that problem, right? We got to think the problem through. We got to see, how can we break that up, right? Does that make sense? How we get, y'all, are we all good how we got the 12? Okay, just wanted to make sure. Just want to make sure we got the 12. Okay, so look, y'all, this one should be easy breezy cover girl, right? What's the area for this one here? 45, right? Is that one of my answers? Okay, y'all, so this is a good question. She was asking right now, it's always going to be square miles. Remember, with area, it's always going to be square. I want you to notice how they're doing it. What did they put in the front for square, right? SQ for square, right? So whether it's going to be a miles with a little power of 2, or whether it's going to have an SQ with miles or meters or whatever it happens to be, that's how they're going to write it. Okay, that's how they're going to write it. Excellent, y'all doing great. Okay, so look, y'all, we want to find the area of the geometric figure. Again, for a triangle, y'all, the formula is the base times the height divided by 2. So anybody know what 7 times 8 is? 56 over 2 is going to be 28, right? So what's going to be my choice here, y'all? A, B, C, or D? B, right? Again, notice square yards, right? Yes, ma'am. They'll give you the formulas. Yeah, they'll give you for those kind of problems. Like what I'm going to tell you is think about it this way. Remember, for area, I'm always going to multiply, right? If it's like a square or rectangle or a parallelogram, guys, a parallelogram would be like if I were to take if I were to take my iPad, if I could kind of make it to where these sides kind of tilted like this, or like you see what I'm trying to do, right? Like I do a little of that. It's just going to be multiplying. The only ones you really got to worry about is when you have a triangle. You still multiply, but then you divide by 2. So that formula that you have there is B, and then what's the name? I'm sorry, it's an H. I'm sorry, it's an H. Yeah, it's the base times the height divided by 2. Yeah, and I'm going to show you this real quick. Like, let me show you something, y'all. If I had a rectangle here, I'm just making this up. Okay, look. If that side was 5 and this side was, say, 8, and I'm going to say they're feet. Okay, would you all say the area of the rectangle would be 40 square feet? Okay, now let me ask you a question, y'all. If I drew this line right here, and then I did this, what did we do with that rectangle? We cut it by how much? By half. So wouldn't the area of the triangle now, y'all, be 20 square feet? Does that make sense? That's basically how we're able to get it. Okay. But are they going to give you the formula? I'm going to tell you that they probably are. I don't necessarily think the objective is how many formulas do you remember from when you were in high school, right? Because for some of us, that's right. For some of us, high school could have been 2 weeks ago, right? Or a year ago. And for some of us, high school, like in my case, 31 years, right? It's been a little while, right? Yeah. Yeah, no, it's been a long time. Okay, guys, I want you to notice this problem here. What's the shape of the picture? Triangle. Still a triangle, right? Okay. Yo, the one thing I want to mention, the 18 inches is the whole bottom part. Okay. Remember we said the area of a triangle is the base times the what? The height. Okay, so I'm going to take 12 times 18. Can somebody do me a favor? What's 12 times 18? Big number, 200 and what? But then we have to do what? What's 216 divided by 2? Boom. And there's your answer. Good, guys. You guys are doing great. Okay. So we do have the area of a trapezoid problem. Okay. So guys, let's go back. Let's look at the formula so we can make sure we do this one correctly. We hadn't done any trapezoids yet. Again, if you have a problem like this, y'all, they're going to give you the formula. Okay. So look, let me scroll back up to the top. Do we have it here? Oh, okay. I didn't give it to you. So look, this is what we're going to do. When we don't know, what do we do? We don't do it. I like that too. Okay, area of a trapezoid, right? In case you forget. Okay. Okay, so look, y'all. We have what we call there's like two bases. So this piece right here and this piece right here, we're going to add them together. We're going to divide it by 2. And then we're going to multiply it by the height. Okay, so look, let's come back over here. So what we're going to do, y'all, we're going to say, look, and it's just the formula that the way they wrote it. A lot of times they call this base 1, they call that base 2. Okay. This piece right here in the middle, y'all, That is our height. So the way we find the area of a trapezoid is we're going to take base 1 plus base 2 divided by 2, and then we're going to multiply it by the height. What we're doing, y'all, when we take two numbers and we add them together and we divide by 2, we're finding the average. So they're saying, look, if that piece is 8.5 and that piece is 10, what would kind of the middle piece kind of be, right? So look, we're going to take our numbers, 8.5 plus 10 divided by 2 times what number here? 5. Okay, let's take our calculator. Oops. Let's figure out what's 8.5 plus 10, 18.5. Let's divide that by 2. And then we're going to multiply it by what number in this case? By 5. 46.25. Is that one of my answers? D, right? Again, y'all. Well, the height, think about it this way. If you could take this, I'm sorry, if you could take this picture right here and flip it, or if you're looking at it like that, the height is at middle. Yeah. So if you thought about it, boom, flip it over like that. Here's this base, boom, there's your height, right? But I agree with you. I agree with you. Height, I normally think of going up and down. Yeah. Yeah, guys, her question is, if you notice also, y'all, look at how they did the height. Do you notice right here? See how they have those little 90-degree angles? Because that's the height, right? That's the part that goes from those bases to the bases. Yeah. Excellent question, guys. Y'all are doing great. Okay, so y'all, okay, this is what I was talking about. Remember I told you earlier that sometimes there's another approximation. Now again, you said when you took the test, you always saw 3.14, right? That's when you saw. Okay, so guys, I'm not telling you that you're going to see the 22/7. All I'm telling you is that if you did see the 22/7, how would you go about doing this? Okay, so I'll tell you what we're going to do. I want us to do this problem. We're going to do three things. We're going to find the exact answer. We're going to find an approximation using 22/7, and then we're going to find a third approximation or a second approximation using 3.14. So again, I just want to walk you through this because I want you to be aware if you come up with a problem like this, what would you do? And I don't want you to say, man, we only did it like this, we didn't do it like that. I just want you to know what you would do. Look, y'all, there's a formula for the area. The area says pi r squared. So look, first thing we're going to do, we're going to find our exact answer. Okay. The formula says pi r squared. We're going to take pi. The radius, y'all, just goes from the center to the outside. It's like half the diameter, right? From the middle to the outside. In this case, my radius is what? Okay. Y'all, remember on Friday, one of the first things we did was order of operations. Do we have any exponents here? What's 5 when you square it? 25. Good. I'm so glad y'all didn't say 10. Look, 25 pi, right? Now, y'all, what was my units here? Centimeters, right? But because I'm doing area, it's going to be centimeters what? Squared. Very good. Boom. Excellent. Guys, that is what we call the exact answer. Okay. Now, this is what we're going to do.
But we still have to multiply it from the 3.15.
Okay, so now we're going to do approximation number 1. The first time it says pi is going to be what number? Well, hold on. Look, see how it says here 22/7? So look, this is what we're going to do. We're going to go area equals 25. Y'all, I'm going to think of that as 25/1. Okay. Times 22/7. Okay. Because it said, look, let's use 22/7 for pi, right? Okay, let's go slow. 25 times 22, big number. 550/7. Okay. Now, guys, what I will tell you is, like, if we were in an algebra class, improper fractions are perfectly fine. But again, the next thing is, well, what is 550 divided by 7? What does that really mean? Okay, so before we do the decimal part, this is what I want to think about. I want to think about back when we were like in fourth grade or fifth grade, something like that. If we were going to divide 7 into 550, number one, does 7 go into 5? No. If I wanted to know, does it go into 55? Would you guys agree with me that we would look at our 7, we would go here, we'd say, what's the first number closest to 55 but doesn't go over? 49, right? How many times 7 go into 49? Okay, so we'd come back over here, we'd put a 7, we'd put a 49, we would subtract 55 minus 49 is going to give me 60. And then I would come back to my table again, right? Right here. And I want to go 7. I want to find the first numbers closest to 60 without going over. And it would be what number? 56, which goes in 8 times, right? So look, we're going to go 8. We're going to put 56. What's my remainder, y'all? 4, right? Okay, now remember how we write this out? As a mixed number, y'all, this is 78. How much was left over? 4 out of the, okay, this was what? Centimeters, what? This would be the approximation using the 22/7. Did it make sense how we went about doing it? Okay, so let's come back and make sure that we're okay. Y'all agree we already had a 25?
Yes.
Okay, all I did, y'all, is I wrote it as 25/1. Why did I write it over 1? Because they gave me a fraction for my approximation, right? So if I have a fraction, I want to think of 25 as a fraction by just writing it over how much? Right, then we went straight across. 25 times 22 was? Then we divided by 7, and then we used our table, right? That's how we were able to do it using our table, and that's how we came up with this. Now again, the reason why I want us to write it as a mixed number is when I say 550/7, what does that mean? That means 78 and a little bit more, right? 4 sevenths. This is typically how we think of big numbers, right? Instead of thinking about it like that, we normally think about it this way. Now, y'all, the second approximation, or the third thing we're going to do in this problem. Yes, ma'am. Of course, of course.
Okay, wait. I know where the 78 came from, but I know where the 4 came from. Where did the second, how did this come?
What number was I dividing by?
Okay.
Better?
So that thing next to the 40 in the left, what is that? That's a square root? No.
Oh, that's the letter R for remainder. I'm sorry. That's my R for remainder. I'm sorry, guys. Second grade, guys, and my report card in second grade under handwriting, D, like that. And it never got better. From second grade on, it never got any better. I apologize.
I thought it was a square root, I'm like.
No. I'm sorry. It's remainder. The remainder is 4, right? Okay. Look, y'all. The third thing I'm going to do here, I'm going to do my second approximation. Pi is 3.14. Okay. Remember what we got? We had a 25 pi. I want to say it was centimeters squared. So all I'm going to do here, y'all, 25 times 3.14. There you go. You got it. Right? Okay, which is the easiest approximation to do? Obviously this one here, right? And again, guys, I hope that when you take your test that they don't ask you 22/7. What I want you to be aware of is if they do, I don't want you to say, man, I don't know what to do. I want you to say, look, I'm just going to go straight across. Now, guys, I want to show you something because when you go take the test, you know what you're not going to have? That, right? Okay, so look, this is how you're going to do this. Okay, we're going to go like this. What number are we dividing? 550, we're dividing it by what? Okay, so look, let's go like this. 550 divided by 7 is, oops, I put times, sorry. Eeks. Okay, look what we came up with. 78 point and a whole bunch of stuff, right? Okay, forget about the whole bunch of stuff over here. Pretend that's not there. Just do this. What's 7 times 78? 546. Okay, so this is what we're going to do. And we're going to subtract. What's 550 minus 546? Isn't that my remainder? that make sense?
So you
Okay.
should do it like that from the beginning.
Well, again, okay, but what I want you to, well, look, but this is the thing, right? If you have kids at home and they're in fourth grade or fifth grade and they're, mom, how do I do long division? I don't want you to, yeah, I don't want you to say, I don't know, go ask your dad, right? I don't know, I don't want you to tell them that. I want you to know how to do it too, y'all. But again, I'm showing y'all this, y'all, because look, y'all, in fourth grade, I had a really great teacher, Mrs. Gatto. Mrs. Gatto showed me how to do this. Guys, even though I struggle with math and a lot of other grades, I knew how to do it because of this part here. And I think that helped me a lot. And, I was lucky to have Mrs. Gatto as my teacher. But, and I know not everybody had a Mrs. Gatto, but what I want y'all to do is to know how to do it. But again, you're not going to have this on your table, on your test. But so that's why I'm showing you how to do it on the calculator at the end. But again, if you have little kids, mom, how do I do a long division? And you show them how to do it like this, and they go back to school, but the teacher will say, that's not what I'm asking you to do, right? So that's why I'm showing you the other thing. Yes, ma'am. Okay, good question. Right here. Remember when we did our problem, when we started off from the very beginning, the formula is pi r squared, right? Okay, remember what my radius was? My radius in this problem here was what number? Was 5, right? Remember, it's 5 squared though. What does 5 squared mean? It means 5 times 5, right? And 5 times 5 is 25. That's why I said I'm really glad that nobody told us 10, right? Because it's, huh? Oh, okay. Yeah, yeah, you can do that. Yeah. Yeah, you can do this here, 5 times 5, right? Which gives me that 25, right? Because that's what 5 squared really means. Yeah. Good question. Good questions, y'all. Okay. All right. So, guys, we still have some area stuff to do here. So let's see if we can finish this up before the day is over. Find the surface area of a solid. Use 3.14 for pi. Okay, so look, y'all, I'm looking at my picture here. Okay, the surface area means this. So think about that, y'all, as a shoebox, or like this box right here. What I want to know is what's the area back here? What's the area here? What's the area here? What's the area here? Here and here. So look, if I think about this area in the front, y'all agree there's another one in the back?
Yeah.
There's 2 of them, right? If I think about this area right here, there's one on the back, so there's 2 of those. And if I think about the top, there's also the what? The bottom. Okay. So look, this is what we're gonna do. Let me zoom in here, y'all. If I wanted to find the area, say that rectangle right there, would you agree we're gonna take 6 times what? Okay, so look, let's find the area. I don't know, I'm gonna call this 1 and 2. So look, area of rectangle 1 would be 6 times 3, which is 18. Everybody agree? Meters squared? Okay. Would y'all agree that area 2 is also going to be 6 times 3? The other side, right? Because remember, there's going to be 2 of them for all of them, right? Okay. Now look, let's do this. So are we good on that part?
Wait, so couldn't you just, sorry, but couldn't you just find one and then multiply it by the amount of number that there is?
Okay. How many are there? Okay. So 18 and 18 is 36, right? That's all we're doing.
Oh, you're just breaking it.
I'm just breaking it down for you guys. Okay, guys, can I clean up what I wrote here?
No.
Okay. No, you're good. You're good. You're good. No, you're good. You're good. I don't want you to apologize. You're good. I just want to make sure that we're good in how we're doing this.
I was trying to process what.
Yeah. No, but think about it, guys. So again, I don't want you to make this harder than it needs to be. When I find the area of this one here, you agree I'm going to double it because I got another one here. When I do this one here, you agree I'm going to double it because I got this side. When I do the top, you agree I'm going to do the bottom. Come in. Okay. So look, that's why we have the 2 of them. Now, let's do this, y'all. Let's do this one here, and that's also going to give me that one over there. Okay. So look, if this side is 3, y'all agree that side's also 3? Okay. So look, for the area for that rectangle, it's going to be 3 times 4, which is going to be what? 12 meters squared, because we're going to have 2 of them. Now that's going to give me what? 24. So far, we got the sides and we got the front and the back. ¿Verdad? Are we good so far? Now we need the top and the bottom. Y'all agree? Okay. So look, y'all. Can I clean up this right here? Okay. So look, let's do this. Let's do the top, and then we'll do the bottom at the same time. Guys, y'all agree that long piece is 6? Okay. How much is this one here, y'all? 4. Perfect. Okay. So look, y'all, we're gonna go 6 times 4. That's 24 meters squared. But we have to do what? We got to do double it. Good, y'all. Y'all are doing great. 48. Okay, now, y'all, what am I going to do with my numbers 36, 24, and 48? We're going to Adam and Eve, right? 36 plus 24 plus 48, 108. Is that one of our answers? Boom, there we go. I'm not going to erase anything. Again, y'all, I was just trying to break it down for you guys, right? I was trying to break it down that, again, when I'm finding the area of this, if I find the area of this side, I know I got the other one on the back. If I find the area of this side, I got to know not this one on the side. If I find the area of the top, I got to know I have the other one on the bottom at the end, right? And that's the surface area. So it's just like the outside of the box, right?
So I have a question.
Ask me.
So on the paper right here that you give us the area,
Uh-huh.
the rectangle says that the area is equal to the length times the width.
Right.
Would it be okay to say 2 times the length?
For when you're doing surface area, yeah, because we're going to double them, right? We're going to have the top and the bottom. We're going to have the sides. We're going to have the front and the back. But the only time you're going to double them is because we're doing the box, right? So if I have this side, then I have that side too, right? If I got the left side, then I got the right side también, right? If I got the top, then I also have the bottom. That's the only reason we're doubling them, right? Because we had top and or front and back, right? We had left and right. We had top and bottom. That's the only reason why we doubled them, right? Does that make sense?
So how are you using 3.14 for height?
Oh, okay. Sorry. Good question. Okay, so guys, when I pull these problems, I use a computer program to generate these problems. Sometimes they put the 3.14 for pi if you need to use it, but like in this problem, we didn't need to use it, right? Okay, but it's a very good question. I'm glad you asked that, y'all, because I would be in the same boat. I would say, hey, hold on, where am I going to use the 3.14? Well, if my problem had something where I had to use a pi, then I would do it. But because this one doesn't, I don't need it. But it's a very good question if you ask. All right. Okay, guys, would we do this one the same way? Okay, now let me ask you a question. That is a very specific type of box. All the sides are what? Okay, so y'all, it's kind of like we have a Rubik's Cube, right? Wouldn't the top and the bottom, the left and the right, the front and the back, they're all going to be the what? They're all going to be the same. Okay, so look, if we were to find the area of that square right there, it would be 7 times 7, which would be 49 what? Feet squared? Okay, but hold on, look. This is 49, this is 49. This is 49, this is 49. This is 49, this is 49. How many sides do we have? 6, right? Front and back, left and right, top and the bottom. So now we got to take this number and we got to multiply it by what? By 6. 294 square feet, right? Okay, did we have to use the pi here? Nah. Okay, good. Excellent, y'all. Okay. Volume. Volume. Okay, guys, we're almost done. I know it's been a lot. If you got to stretch your legs, get up, go to the bathroom, whatever, go ahead, But we're almost done here. Okay, volume, y'all. Let's take a look at volume. Find the volume and the surface area of a rectangular box that's 12 inches long, 6 inches wide, 3 inches high. Okay, so one thing I want to mention here, y'all, look, volume, length times width times height. Okay, volume, length times width times height. Okay, what is and again, remember, y'all, we're multiplying. What number do I put first or second or third? It doesn't make any difference because we're multiplying. What numbers am I going to multiply here? Times, yeah. And does it matter what order I put them in? Nah. 6 times 12 times 3. Okay, so let's do this. 6 times 12 times, oops. 6 times 12 times 3 is 216. Now, y'all, the one thing I want to mention about volume. So remember when we did area? Area was in square units. Volume, y'all, is in cubic units. Okay. I want you to think about a lot of us now, when you go home and you go get water, a lot of us have that refrigerator where you push the little thing and ice comes out, right? But like I don't have one like that. But when I was a kid, we had ice cubes, right? Think about this as your ice cube tray, right? Aren't each of them little square or little ice cubes? That's why each one of them are going to be cubes. Okay. So guys, one thing I want to mention. Sometimes we write it like this. The other way they write it, 216. Yeah. And they go cubic inches. That's supposed to be a U. Yeah. See you. I see you later. So CU inches, right? They'll write them like that. So whether it's inches to the third power or CUIN, that's what they're really referring to. Okay. Okay. So y'all, I got another problem here. Again, still dealing with volume. And it says, find the height of the figure below with the given volume. Well, it could be. It could be. I'm not certain for sure. But look, this is what I want us to do. I want you to think about the formula for the volume. It's the length times the width times the height, right? Okay, look, we already know what the volume is, right? The volume is 1728. Okay. The length is 12. The width is also 12. I don't know what the height is. It's possible that it's 12, but it doesn't necessarily need to be 12. This is what I want us to do. Look, y'all, 1728. Anybody know what 12 times 12 is? 144 times h. Remember, when we did this, when we did the percent problems, y'all, if I'm trying to solve for h, and right now it's being multiplied, what's the opposite of multiply? Let's divide everything by 144. Okay. So if I take my calculator, 1728 divided by 144, 8, very good. It's 12. Okay. Now, the only thing the only reason why I said, look, I don't want to just write a 12 off the bat is it could have been a different number. Yeah, it could have been a different number. And it's not always like, well, if I look at the picture, well, this side kind of looks like that side kind of looks like the other one. Sometimes the pictures are drawn a certain way, but it doesn't necessarily mean that they're the same numbers. But the process and how we did it was the same. Okay. All right. So take a look, y'all. The next one here, I have the volume of a cone. So the formula for the volume of a cone, I'm going to zoom in so we can see this real quick, y'all. So look, the formula says 1/3 times pi times r squared times h. Okay, so look, we're going to do our problem here. Okay, so look, y'all, first thing I'm going to do, I'm going to write down my formula. Volume equals 1/3 times pi times r squared times h. And I'm just going to fill in the blanks. Okay, y'all, I want you to notice something here. They do want an exact answer and an approximate. So look, let's do the exact one first. I'm going to go 1/3. Y'all, since I have a fraction here, I'm going to think of this pi as pi over 1. Okay, what is my radius in this problem? So look, we're going to go like this, 3 squared over 1. Okay, I'm thinking of everything all as fractions as being over 1 because I have a fraction. Times the height. What's the height of that cone? 14 over 1 again. Okay, now look, y'all, we're just going to go real slow here. What's 1 times pi? Okay, but let's keep the pi symbol as it is. But everybody agree 1 times something is whatever that something is? So 1 times pi is still going to give me a pi. Anybody know what 3 squared is? Remember, 3 squared means 3 times 3, which is 9, okay, times 14. Let's do the bottom part, y'all. What's 3 times 1 times 1 times 1? Still 3. Excellent. You're doing great. Okay, let's go straight across. Pi times 9 times 14. I don't know. I'm going to take 9 times 14. 126 with a pi divided by 3. So remember, all I did here, y'all, 9 times 14. That was 126. I put the 126 with the pi divided by 3. Now, if I can, y'all, if I can, I want to see if I can divide that out. Comes out nice and neat. Everybody agree? 42? Okay, look, y'all, 42 pi. This is going to be my exact answer. What were my units? Centimeters? So look, y'all, I'm going to write cubic centimeters.
So I have a question.
Ask me.
So why is it stuff come like that?
What do you mean? If what part? What part didn't come?
The pi thing. What if they have the exact numbers, like 42 multiplied by 9?
Okay, so remember, we're going to do the approximation now. Because remember, we are going to do the approximate answer. We're going to put the 3.14 for pi now. You know, remember when we did this problem?
So that one would be like the exact.
That's the exact answer. And now we're going to do the approximation, right? So guys, do y'all agree the approximation is just going to be 42 times what? 3.14? Okay. I got a question for y'all. If I'm going to go one decimal place, 131.8 or 131.9? 0.9. Okay, good, y'all. 131.9. Again, cubic.
So,
Ask me.
so you know how in the exact answer you did the 126 over 3? What is the, on the approximation, you do 126 times the 3.14 divided by 3, it should be the same number.
It's going to be exactly the same thing. It'll be exactly the same thing. So guys, her question is, from this point here, if I didn't just do this part here, but I plugged in the pi for here, would somebody do me a favor? If you have your calculator, will somebody do me a favor? What's 126 times 3.14? And then take that number and divide it by 3, and tell me if you still get 131.9.
Yes.
You still do. It's still going to work, right? Guys, if you all remember from last Friday, I said, look, one of the nice things about math is that it's always like 5 times 5 is always going to be 25, right? It never changes. Same thing here. All we did here is we divided and then we multiply. Well, what happens when we multiply and then divide? We're going to get the same thing. Okay. We're going to get the same thing. Excuse me. Okay, circular cylinder, y'all. Circular cylinder. We're going to find the volume of the cylinder here. Okay, again, I want you to notice something here, y'all. For this problem, they do give me the volume formula right there. Okay, the volume is pi r squared times h. And we're going to use the approximation using 22 over 7. Okay, again, we'll do the 3.14 también. I just want to make sure that if you get a problem like this, that you know what to do. Okay, so look, y'all, first thing I'm going to do, I'm going to do my exact answer. Okay, so the formula says pi r squared times h. So pi. If I look at this picture here, y'all, I'm going to zoom in on it. I want you to notice what they told me was 2. The whole thing was 2. So look, if I were to look at that circle right there, could you tell me what the radius would be? Everybody agree the radius is going to be 1?
Yeah.
Okay, so look, let's do this. The radius is 1. That's going to be 1 squared times the height. The height is the same thing. Remember we said before, you were saying like, well, you know, I thought the height always goes up and down. Turn it up, right? Turn it like this. Like it's like your roll of paper towels. Turn it this way. The height is what in this case, y'all? 9. Okay. So look, we're going to do the exact answer. This is going to be the exact answer right here. Question. What's 1 when you square it? 1. What's 1 times 9? Still 9. So you look, y'all. My exact answer is 9 pi cubic inches. Right? 9 pi cubic inches. Okay, because we did this a little while ago. Look, y'all, I'm going to write this 9 as 9 over 1. I want you to notice what they're telling me to use now. They're telling me to use what number? Okay, so look, we're going to go like this, 22 over 7. We did this a little while ago, y'all. So look, I'm going to put a 7 here. What's 9 times 22? 198? Okay, guys, we did this a little while ago. Remember how I did this using my calculator? So again, I know how to do it using the 198. Do what? Divided by 7 is how much? 28 and something, right? So we know it's going to be 28. Okay. How do we figure out what that other something is? So look, we're going to go like this, 198. We're really dividing it by 7. We know it's going to go in how many times? 28. So let's do this. What is 28 times 7? 196. What is my remainder? 2. So wouldn't I write this as 2 over? Okay. Cubic inches, right? And here is my approximation where we use 22 over pi, right? Or 22 over 7, I'm sorry. The second approximation, y'all, would I just take 9 times 3.14? Okay. 9 times 3.14. 28 point what? If I was going to go to one decimal place, y'all, what do you think? 28.2 or 0.3? 0.3. Perfect. And there you go. Right? So again, y'all, I'm not telling you that you're going to see the 22 over 7. But if the problem was there, I wouldn't want you to say, man, we didn't do this. I don't know what to do. You know what to do, right? If it's 3.14, come on, that's pretty easy breezy, cover girl. You know you're just going to multiply by 3.14. But if it isn't, I want you to be aware, how do you do it there? Okay. All right. Okay, look, y'all, we got a little bit more to deal with pyramids and volumes. Again, we're going to find the volume. Guys, for the only time I'm using the pi is when I have a what in my problem? When I have a circle, right? If I have a circle, I'm going to use my pi, right? That's the only time I'm using the pi. If there's anything with a circle on there. If I don't have a circle, I don't need to use the pi. So I look at this problem here. Hey, you know what? There's no circle. So we're not going to have to use pi. We're just going to use the formula. Volume is 1 over 3 s squared times h. Okay, you might say, what is the s? Y'all, these are going to be squares on the bottom. The bottom is going to be a square base, meaning the sides of that bottom is going to be a perfect square. Whatever you got here is going to be the same thing you got there. So look, if that's 5, y'all agree that other piece over there has got to be 5 también? Okay. So look, we're going to go, we're going to go like this. Volume equals 1 over 3. Now the side was 5 squared, right? Y'all, I'm going to write that over 1. Okay. Times the height. What was the height of that pyramid? 9. I'm going to write that 9 over. Okay. So look, let's keep working here. 1 over 3. Anybody know what's 5 squared? 25. Good. Over 1 times 9 over 1. Okay, let's go straight across. 25 times 9 is 225. Y'all, what are we going to get on the bottom? Okay. What are we going to do now? Let's divide it out. 75? Nice and neat? Okay. What are my units going to be here? I'm dealing with volume. Is it square or is it cube if we're dealing with volume? Cubic, right? So look, y'all, cubic centimeters, right? If you wanted to write it like this, that's fine too. Remember, guys, area, square. Anytime it's volume, it's always cubic units. Volume takes up space. If you think about this room here, if I had a ton of these boxes, we could line them all up. We could start stacking them up, stacking them up, stacking them up. We're going to have a bunch of these. I know they're not perfect, but think about them as perfect cubes, right? Because we're filling up all the space this way, and that way again, right? That's why we do cubic units when it comes to volume. Okay. All right. Hold on. Well, guys, again, I trust me, guys. I mean, I'm tired too, but I want to make sure that we have time to finish everything. So I'll tell you what. Let's just do a tiny bit. I want to see where we're supposed to stop for the day. Okay. Um, Let me come back and look at my daily schedule. Is that it? Do we stop the geometry? Oh, look, guys, we're barely right here, so we still got a little bit more to do. I'll tell you what. Let's just do this one part right here, guys. We'll be done in like 10 minutes, and then we'll call it a day. I know everybody's tired, guys. I'm tired too, and I don't want to overwhelm you guys. But what I'm more concerned with, y'all, I don't want Tuesday to come around, Wednesday to come around, and I stop right here and I haven't shown you this stuff. You know what I mean? So we're just going to do a little bit more, and we'll call it a day. But we'll figure out how we can catch up. If I'm going to look at the material for the next 2 days, guys, if I got to kind of thin it a little bit, I'll do that because I want to make sure that we're good. Okay, I'm just going to do like terms. It's just maybe like 5 problems, guys. There's something called like terms, unlike terms. Easiest way to think about it. You go to HEB, you buy apples. There's a bunch of different apples up there, right? If you get your bag and you start getting red apples and green apples and everything, and you're putting them there, and then we go to the checkout, what are they gonna do? We're gonna separate them, right? Why? They're apples, but they're all different, right? Same thing here, y'all. Look at what like terms and unlike terms are. Like terms, they both have what letter? They both have what letters? They both have X what? Okay. This one is an X squared, that's an X. They're not the same. This one has an XY, that one has an X what? They're not the same. That's what I mean by like when it comes to the apples, right? You can't just put them all in the same bag because they're going to separate them. Okay. All we want to do for this first problem, y'all, list the terms of the expressions. The terms, y'all, mean each of the individual pieces, right? Or list the like terms, I'm sorry. Okay, so look, I want to ask you a question. If I look at this piece right here, excuse me, what letters do I have there? PQ. Do I have any other PQs? This one right here. Those are like terms, okay? So let's see which ones are like terms. Well, 8 PQ and negative 5 PQ, right? Those are like terms. Okay, look at these here. Are they the same or are they different? They're different. One of them has a P, but the square is on the Q. The other one has a square on the what? On the P. So they're not the same. Those are what we call our like terms. Okay. Okay, let's do the same thing here. Let's go through our like terms. Let's see which ones are like terms. Would you guys agree that this one here and that one there are like terms? Because they're both x to the 6. So look, I'm looking at this part. So far, that looks good. Okay. Would you agree the 6x squared and the minus 2x squared are like terms? Okay, so far A is looking really good. Okay, let me ask you a question. Is this guy here and that guy there like terms? No, one of them has an X and one doesn't. Okay, so that's not true. So which ones are like terms? The X to the 6 and the what? And the X what? Squareds are like terms? Does that look like choice D to me? There we go. Those are my like terms, right? The negative 6 and the 7x, guys, they're not like terms, okay? One of them has an X, one does not, okay? We're just trying to figure out what like terms are. Again, y'all, we're just going to do a handful of problems. We'll call it a day here. Look, combining like terms, y'all. Combining like terms just says this is what we're going to do. What letter do I have? X. We're just going to combine the numbers in front. What's 4 plus 6? 10. That's all you're doing, okay? That's all you're doing. Look, y'all, we're going to do the same thing here. Look, there's a Y. That's a Y, that's a Y. What's the number in front of this Y if I don't see it? 1, right? Okay, so we're going to get there right now. I want you to think about this for a second, y'all. I have $1, but I owe you how much? 5. If I gave the $1 that I owed, that I have, are we cool or do I still owe you money? How much money would I owe you? And because I owe it, what kind of 4 is it? Negative 4y. You see that? All we're doing is we're just combining the numbers. What happens to my letters? They stay exactly the same. So notice, y'all, those are x squareds. I'm going to write the x squared right there. Okay. Y'all, what's 3 plus 5? There you go. What about the minus 2? It comes along for the right. You can't do anything with it. It's just 8x squared minus 2. Okay. Look, we'll do the same thing here. 2y plus 4y. How many y's do we have now? 6. Okay. Y'all, I want you to look at the numbers that we have, and I want you to look at their signs. Remember, positives, how much money I have. Negatives, how much money I owe you. I owe you $6. Cindy Rabbit, you lent me another 8. How much money do I owe you now? 14. And because I owe it to you, what kind of 14 is it going to be? If I owe it to you, though, right? So if I owed you 6, and before I paid you my 6, I borrowed another $8 from you, you would say, hey, sir, before Wednesday, you owe me 14. Okay. All right. Let's do the same thing here, y'all. We're going to go one piece at a time. Let's take care of the x's. 6x, right? Okay. Let's take care of the y's. Yeah. Oh, I'm sorry. Thank you. See, my brain is already fried también. Look, 3y, guys, minus 10y. I have $3, but I owe you 10. Positive or negative? Negative, right? Good. You guys are doing great, right? If I have $3, but I owe you 10, and I give you the 3 that I have, you say, hey, don't go anywhere too far because you stole me 7, right? Look, negative 5, positive 11. I owe you $5, but I actually have 11. Positive 6. I have enough money to pay you, and I'm still left with money over, right? So that's why it's positive. Very good. Yes, ma'am. No, very good question. Guys, her question is, does it matter which do I put first or second? The order doesn't make any difference, y'all. What's important is if you put the 7y first, what do you have to put in front of it? There you go. The order what you place them, y'all, doesn't make any difference. Just if the number is negative, bring that negative. If you want to put it in the front, that's okay. Okay, guys, let's call it a day there. We will pick up the rest of this tomorrow. I'm going to look at the schedule, y'all, to see if I can kind of fit a couple of things out, because again, the main thing, y'all, I do want to make sure that we hit all the important topics.